Welcome to the first video episode of the Bittensor Guru. I am your host, Keith, and I am live here with Carro. Thanks for joining, man.
Thank you for having me. It's great to be here.
Yeah, so you're kind of one of the foundational figures in the Bittensor community. So for me, I've been in this project for almost 2 years now, and you're one of the kind of like original foundation, Opentensor Foundation members that at least I've been aware of. You've recently spun off your own subnet that's been running ever since we originally launched Subnets, which is going on I think 5 or 6 months now. So maybe you could start off here by just telling us like how you got involved with the foundation and Bittensor originally, and then how that kind of like evolved into you now doing your own thing.
Yeah, so I've always been interested in decentralized or at least peer-to-peer networks. One of the real advantages to peer-to-peer is its affordability. So growing up, I didn't have these big fancy machines, I loved things like Grooveshark and Napster and LimeWire. And one of the main problems with something like Napster is that it makes that affordability really good, but you sacrifice on speed and security. You'd be downloading viruses all the time. And so Spotify came along and was able to offer a cheap, safe, and fast alternative where you could stream any song that you wanted. This really kind of took the sales out of something like Napster. And it's actually one of the main innovations of like what Bitcoin did. When you hear someone like Jamie Dimon, he's like, what's the point of Bitcoin? It's a pet rock. The real innovation, at least from the technical perspective, in my opinion, is that they were able to have that affordability of like a payment network that is peer-to-peer, but also the security. So, there's never been a double spend on Bitcoin. This is, more than a decade later. And so I think where we are today is we're kind of in this third wave of peer-to-peer. And I was participating in that in 2020. I was working on reinforcement learning for portfolio management and compute. We didn't have compute like we do today. Like a couple of years ago, especially during the 2080 Ti kind of era, the V100 kind of era, getting a hold of compute was very, very difficult and also very expensive. And so I was doom scrolling late one night on GitHub looking for a way I could run my experiments for cheaper. And on like the 7th or 8th page of GitHub, or in like November of 2020, I found Bittensor. I loved the name, first off. The name was great. When I saw it, I was like, oh, this is killer. And then I start reading the GitHub repository and I say, hey, this is a really great idea. If these guys ever drop this, like I'm totally gonna pick it up and keep working on it. And so I kept watching it for a couple months. And then around like January, February timeframe of 21, they launched the network. This was Kusanagi. And they had added a Discord in the README. So I joined the Discord. I started befriending Const and Shib. And, we just kind of took it from there, and so they asked me in November of that year when they relaunched Nakamoto. They asked me if I wanted to join. I was over the moon, ecstatic. Like I was like, yes, this is like my big break. And I was able to, become a really good developer there under the leadership of Constant Shib. I learned a lot from them as mentors, and we had there was a lot of struggles trying to scale the chain in that time on Nakamoto when it was just one thing that we were doing at the time, which was like basically just inference. And so we come up with the idea for subnets, and because that was what I was looking for, was my ability to have I could establish or say, I want to grow this amount of compute to do this particular thing. And then like if I wanted to do something like training a reinforcement learning model, you could do that, right? Now, this is where I think Bittensor is really like the next iteration of these peer-to-peer networks, because we are we're able to solve a lot of the issues that Bitcoin has in terms of speed, right? Uh, Everything, I think it's almost forming like a crab where everything's kind of taking this shape where it's like you're going to have all of this really hard work done off of the chain, and then we submit the verification to the chain. Bittensor works very similar to how a lot of the same first principles of a lot of L2s, where they submit to the work to Ethereum. You can think of these L2s as like validators in Bittensor. They're essentially doing the same thing, albeit in their particular use case. If there was a subnet built to do like something like Arbitrum, I think it would work in a similar way. And so, that's when we were able to create subnets. I had always wanted to be able to use Bittensor to build really great and awesome applications that a bunch of people could use. And so that's kind of how we got here with Manifold. And, we're growing our team and we have an office, and yeah, it's pretty great.
Yeah, you talk about these different waves of like decentralized peer-to-peer networks. Whenever Napster was around, when I was in 7th or 8th grade, I had a business. I even had a girl that was a salesperson for me, and she would go around and get these orders for like CDs, basically, that would have like my advertisement. My claim was like, I can find any song you've ever heard, 20 tracks, like you give it to her, she makes $2, we charge like $10 for the disc, and then I go home and on the 56K modem, I like download the 20 songs. It takes like 3 hours. I leave it on overnight, and then I'm like burning the CDs in the morning, and then she would like deliver them to the person. I had this one guy who was like obsessed with Depeche Mode, and he was like always ordering CDs. His name was Jason. He's like my #1 customer. But that was like, and like as far as being involved in this stuff from like an early age or whatever, I never got into programming. Like I did a little bit of like HTML stuff when I was younger, but like that's kind of probably why I've gravitated towards the validator role, because it's like not very technical. You can almost use like ChatGPT as a crutch to like figure out all the Python things that you need to know. And if you've got like some experience and someone to ask for help with that, you can kind of figure your way to making everything run with kind of duct tape and glue and everything else. But you were talking about scrolling through the GitHubs now of back in 2020 of, random projects and things like that. What is your background that allowed you to like prepare for looking at some of the code and things and seeing the potential in Bittensor and knowing that it might be something you might want to be involved in?
Yeah. So I had always been kind of interested in programming. I know this is maybe the most tech bro thing you could ever say, but I would do these when I was a kid. I would work in construction. So anytime they would be doing like a big housing development near me, I would ride on my bike and go over there, and I would pick up trash for $5 a day during the summer. And I'd saved up my money all summer to be able to buy a laptop, a Toshiba laptop, and the movie, The Social Network. And because I had seen Spider-Man, and I liked Andrew Garfield because I like Spider-Man. Anyway, so I buy the movie, and because back in the day, this was like before, internet was in like every home. I would just watch it over and over and over again. It's such a good movie, just like the way that it's written. And so I would like stand in front. I used to know every word, and so I had seen. You see this guy. He's maybe not the coolest guy. He's a little bit of a goof, and he builds something that people like, and all of a sudden everyone likes him, right? And so I had seen that. I'm like, I should do the same thing. So I started building apps like in middle school, trying to See, the problem with building iPhone apps is that you need a MacBook. And when you don't have a bank account or a job, it's like you're not allowed to work really, or at least get paid a fair wage. It's going to be a little unattainable to get that MacBook, right? And so I was building Android devices. I was super into like free music streaming because I didn't have a bank account, so I couldn't use Spotify. And so I was trying to really just learn and build applications that would solve problems that I was having. And then my sister, when I was a freshman in high school, got a MacBook. And so I would use her MacBook at night when she was asleep to build apps. Like, you know, I download Xcode. I begged my grandmother to help me, like, give me like $100 for an Apple developer account. I mean, which at the time was like the biggest ask. I thought I was asking for $1 million. Like, and so the first app I ever made, or was able to like really publish out there onto the App Store, was this app called Flappy Griff. It was like a clone of Flappy Bird, but it was my freshman year's Latin teacher's face. And instead of the pipes, it was Roman columns, and I had the Colosseum in the background, and it went viral at my high school. I mean, 10,000 downloads, which was crazy at the time. I was like, this is wonderful. Cool. And since then, I was instantly hooked, right? Everyone knew my name. Like, it really did work. And so I'd always been trying to build the next thing after that. And I thought, oh, wow, hey, if I could build a program that could like do your homework for you, this would like 10x my coolness. And so I started working with convolutional neural networks to do next character prediction to write essays. This is like 2015. So this is way before transformers. The best thing we had at the time was like CNNs or recurrent neural networks. Needless to say, it did not work very well. But I was still like really into that idea of, you know, being able to like just like to input your essay prompt, it go and search the internet, get all the sources for it, and then write like the perfect essay that gets you the A, right? And then when I was a freshman in college, the transformer paper came out. But reinforcement learning was way more huge back then, because you got to remember in 2016, there was like an AI bubble over self-driving. So this is when like scale AI came about, and there was like all like that first generation of AI companies like OpenAI, Scale, these people in San Francisco, like Cruise. This is when George Hart started working on the Comma and the OpenPilot. And so everyone was using reinforcement learning. Now, reinforcement learning is very hard and very expensive. And so it was not preferred over the transformer. And that's when we started doing things like tokens. So instead of like predicting the next character, we would like teach, like we would have like a vocab, and then like the letters like TH would be its own token, right? And the tokenizer would be like, it would learn this vocab. And then you would use that tokenizer with the transformer. And so you're using things like GPT, with the original GPT-1, right? And GPT-2, to be able to generate these sorts of essays. But the data was not very good. This was like, we were using Reddit still, which you can imagine using if you were going to like create a human and all you ever showed them was Reddit. They might be, you know, interesting to say the least.
That sort of feels like how the world is now, actually. I sort of feel like we have a bunch of like Reddit clones walking around, but I guess we don't have to get into that. So then,
it's
like
TikTok brain rot, yeah.
Yeah, for sure. So then we had, you eventually like had this background in AI that you brought into this like experience with Opentensor. And what was it like? You were with them for like a year or so, or how long was that experience? And maybe you could just talk like a little bit about those early days with the project.
Yeah, so I don't know if it was a year or 2 years. It was probably coming up on 2 years, I would say, maybe like 18 months. But one of the things that we had always been told was that like the foundation was going to be like an ephemeral thing. And I still kind of believe that it will be an ephemeral thing. It's really just there to like get things off the ground, get it bootstrapped. And then, you know, as you see like a bunch of companies and organizations are forming, and then we're going to go through like this new like type of consensus. And so when I was there, I was working more in like a research kind of role where, you know, we made BTLM, which is a really cool language model. We published that at NeurIPS last year in 23. And so being able to, you know, the thing that had interest me, I had built this app called Cowboy Computer that did exactly this. And like, it would generate Q&A. This is like way before ChatGPT too. And so what I was trying to figure out was how can I run this application where you can like paste in your prompt and it searches for you and do it. How can I run that for as cheap as possible? And like on my own infrastructure where I don't have to like do this safety check from OpenAI, right? And this was where we started working on subnets for Bittensor, because with subnets, then you could actually build this application where you can grow the compute. So you define the incentives, right? And in the same way, like Bittensor is like a macroeconomics dream, because you define the environment, you define the incentives, and then it just grows. And so a lot of these learnings, not just from like a product side, where you're building something like people can actually use, and like, you know, that thing that had attracted me to it in the first place. But also, you know, the affordability, the cost savings from just having everyone kind of like, okay, instead of one person running $1 million worth of compute, we have like 200 people run, you know, like $20,000 worth of compute. And I think that in that regard, it's working really well. At least on Sybil, it is. And so, yeah, it was great being able to work at the foundation to help bring this to fruition.
Yeah, and then how'd you get to? So you mentioned Manifold. This is the group that you've created, or the company you've created that runs the subnet 4 on Bittensor, and Sybil's the actual product that you've created, right? This is the front end that's accessible.
Yes, we are working on a search engine right now, and it's actually kind of interesting how we landed on search. I like to say that I'm JEPA pilled. Have you ever heard of JEPA?
JEPA, it has to be a machine learning thing. I think I've read something on it at one point, but I don't remember the details. Yeah.
I tell people about it all the time. It's from Jan LeCun, the head researcher over at Facebook. He published it a couple years ago, and it's his idea on how we're going to be able to create like reasoning systems, essentially. And I did a lot of research on JEPA when I was at the foundation, and we've been doing a lot of research on JEPA, but I've also started basing some research off of this thing called Cicero, which also came out of Facebook in 2022. Have you heard of QStar?
No.
Okay, so GPT-5 is predicted to have the like reasoning capabilities, planning capabilities, instead of it just being like a decoder only like model, where it's just with a fixed amount of compute generating the next token. There's going to be a Monte Carlo search, or like an A-star search. It's also very similar to how AlphaGo in 2016 worked, where they would do all of these different searches to find like these optimal game paths, essentially. The same GPT-5 is going to be based off of a similar system to this. We know that the same researcher that was working on Cicero at Facebook joined OpenAI. And so I think it's very reasonable to say that QStar will be coming out very soon. And so we are also working on something very similar to like having like these sorts of planning systems. And the reason why is because we want to build a very generalist model that can one model that can work on a robot, one model that could like the same model that can run on a robot, can run on a phone, it can run in the data center, it powers Sybil.com. And so being able to build our own index and find you that answer very quickly is in the same vein of the agentic research that we're doing to build these sorts of models. And so uh, with Sybil right now, you can go and what is powered by Bittensor on Sybil right now is the language or the LLM inference. So we have, uh, you know, a few hundred, like 200-ish nodes in Subnet 4 that are all running the same model. And every time you do a query on Sybil, we're able to go and leverage that compute to be able to power the answering engine. Now, we have plans to expand the amount of subnets that we have because we're taking like a microservice, like a microservice approach. So with Subnet 4, that'll handle the like answer or the language model aspect of it, right? We want to build a function calling subnet. We are actually working on this right now. You can see it on our GitHub at Ixtal, so that we can incentivize function calling for anyone to be able to use a generally available function calling API. This is going to be awesome. Like, you'll be able to. We want to use like a very generic function calling model so that anybody could use it in their own applications. Function calling is super cool because it basically allows you to ask, like, if someone types in a query like toothpaste nearby, it will be able to go and find a nearby product and then bring it back to you, all on Bittensor. And then we eventually want to be able to build an index on Bittensor. So anyone could go and there would be like this generally available index of the web that you could go and search. And it wouldn't rely on like Apify or like scraping. Like it would all just be open source. It's all run exactly on that subnet to fulfill the purpose of doing that instead of relying on like third-party APIs. And so we have to do a couple things before that. Like one of the things we're about to push is we've abstracted away the Python Axon API. So now like we can write a subtensor in Go, we can write a subtensor in Rust, we can write it in any language. And we tried to do indexing in Python and it did not work very well. It's not the get speed that's hard, it's the write speed that's hard. And so we want to be able to have all of the components on Sybil powered by Bittensor here in the next quarter or two, as we're able to bring on more subnets to power these different things. What's really important is abstracting it enough so that other people can get value out of the like API you've grown. Like if it's just for Sybil.com, it only works on Sybil.com, it's probably not going to be that useful for other people. And so when we're building these new subnets, this is one of the things we're keeping in mind, is making sure that like other subnets will be able to, like if subnet 8 wanted to be able to query something like Google, you have a generally available search index right there on Bittensor that you could use with the same validator key.
So let's go into two things. One, I just want to make sure that everybody understands what a function call is. So
yeah,
from my perspective, like it's almost like an agent or a value add activity. So it would take, like, for example, like you said, you're trying to source toothpaste near you. It would take your location and it would use some type of function to call a source for the location closest to you with toothpaste, right?
Exactly. So what you do is you can define, it's very similar to how the protocol.py file works in Bittensor right now, where we define all of the different synapses. And so you can define like a get products function it essentially gives tools to the language model. So
Right.
if I say toothpaste near me, and I pass in like the user location, it will output what the function calling model will output is the input to the actual function. So I have a Python function that goes and gets a list of products based off of the product type. Maybe we're filtering by price, these sorts of things, right? You
Mm.
have, it can turn the natural language query, which is like toothpaste near me, into all of that structured data for us to be able to build APIs that the language model can use. Now, this is super useful on something like Sybil because if you were to do, like, we just got back from ETH Denver. We had a great time there, met a bunch of really amazing people. When we were getting our hotel room for ETH Denver, you could what you'll soon be able to do on Sybil.com is say, I'm looking for a hotel in Denver for ETH Denver for 5 people, and then it can go and it can say, okay, I could have a function that's like gather more information, right? So now it can actually generate questions to ask you, right? Or let's say, what's the weather in Colorado? What should I wear? Or what should I pack, right? It can take that natural language query and then generate the input to the function that gets the weather. So instead of having to do like specify the actual, like, like if you go to weather.com and you type in Austin, Texas, like it comes down in a drop down. So it's like there is a discrete list of like cities that you can use, right? Whereas with a function calling model, it's all learned. So if I say, like, what's the weather in Austin, Texas, and then I have another thing that's like units, it's like Fahrenheit or Celsius, it'll just know to do Fahrenheit because it's Texas.
Mm.
You,
Hmm.
see, you know what I mean?
Cool.
Like, I don't have to tell it to do that, which is really cool.
Yeah, so like it's fulfilling the dream that everyone had when they were thinking about like, oh, well, why can't Siri like answer this question properly? It puts an LLM like behind the agent that you're speaking to, right?
Yes, and it will give you, so when you ask a specific question, right, it can interact with a bunch of different APIs to be able to get that information for you. If Siri doesn't know what to do, it just does a Google search and like says, here's what I found on the web. But with something like this, we could have hundreds of functions. And we're actually thinking about including this as a way in our incentive curve or our incentivization, where like the more functions that you can support, the better. Like the better your miner will do.
Cool.
So if I send in my query, which is like, what's the uh, what's like how houses for rent near me, if there's a miner out there that supports like the Zillow API, like going to the Zillow API and interacting with that, it could return that function like, oh, here's the Zillow result. Here's houses near you in text by being able to go to Zillow and use natural language and convert that into like a structured information that the Zillow API understands.
It's like creating a conversational, basically bandwidth with data, right? That sort of seems like what it's doing.
Exactly. If it's taking, it's, you were actually saying this earlier where you said like, oh, this is why I like being on the validator side. First, I wouldn't cut yourself too short. It's definitely running a validator it's an involved process, right? But the benefit of something like ChatGPT being able to help you, like, this is what's so cool about AI. It's inherently deflationary.
Mm.
You're not going to need to spend a bunch of time to learn to code, right? You can just, in natural language, say the requirements of what you want, and it will translate it for you. And so function calling is like a translator for human language into like the Internet of Things APIs.
Cool.
And so what would be great is that any subnet, or will probably have a use case for something like function calling, which is why it's kind of surprising it hasn't been done yet. But we're looking to register here soon, the install subnet, so that we can have like a generally available API for this sort of thing.
And how does this like vary from something like Langchain, you know, like Langchain where you've got these models set up that can kind of like pass information from one to another? This like creates a brain behind the process, rather than Langchain is more like a manual setup, right?
So something like Langchain, first, as a developer, I think it's very opinionated, right? It's either in Python or JavaScript. So now you're constrained to working in those two languages, right? And function calling, all the model does is output a JSON, which is a very generic. It works in pretty much every language. Like we're writing our Sybil, we're rewriting the Sybil backend API in Go right now, and to be able to get like even faster requests. And so I would be able to, within my Go API, if I was using something like Langchain, I would have to write a Python REST API that does all the Langchain stuff that interacts with my Go API. Whereas with something like this, I input my natural language query. It brings me back a JSON object or like a dictionary, a key value based off of like the types that I sent in. So it would work in any language. It gives you, like Picasso, like the artist from like 100 years ago.
I know the old art. This is with the droopy face painting, right? This is one of his.
He drew like he was like a cubist.
Oh, okay.
And he was a very talented artist. If you looked at his art, you would be like, why does it look weird? And and what he was doing, or what Picasso was really great at, was abstraction. And this is actually something that Steve Jobs talked about when they were designing the iPhone or designing products. And he brought up Picasso's bull. So Picasso would first draw like a representation of a bull. And then he'd draw the exact same picture, but he would abstract something away. And then he'd do it again, he'd do it again, he'd do it again, until it's just a few lines, right? And so with something like Langchain and a lot of these packages, like proprietary packages, you have a lot of opinionation, and it's something like a function calling generally available API is like what we're doing with Picasso. Like we're abstracting it away to where any application can take this as an input. It doesn't matter if you're in Go. It doesn't matter if you're in Ruby. If you're using a programming language, it's probably likely that you can interact with key value pairs, and therefore you can interact with that subnet, right? And so that's the real benefit to using function calling over something like Langchain.
Cool. Yeah, and then you also mentioned indexing. So you said that there's, the web is being indexed by your subnet. What does that actually mean? Like I remember when I first spun up the latest or the newer version of your subnet, I was like, I sent you a message on Discord. I'm like, dude, I don't know what this thing's been downloading for like hours. What's happening? You're like, oh, it's just indexing the entire internet. Well, so what does that actually mean? It means it's creating something, a database that's searchable, right? But why are you doing that rather than just going out and searching the internet live when you get a query come in?
So first, being one of the really important things of like right now, I would say in our most recent update, Sybil is like 90% as good as other search engines, right? We are now in a point where I use Sybil every single day. We actually have released an extension that you can install on Chrome that will set Sybil as your default search engine.
Cool.
And that helps us be able to like understand. And like if I won't use Sybil, why would I expect anyone else, right? And so there's so much information out there that is very hard to index, right? This is like YouTube videos or a lot of very like Discord, for example. This is not indexed. Facebook, it's not indexed. And the reason why you'd want to index something is for speed. Google is able to, like, I think their index is in, like, it takes 1 millisecond to do a search through the index. So that's how Google is able to give their responses back so fast. And you also don't want to rely on something like a meta search, which is what we currently rely on. So, or at least on the front end. So back when we were building our own index using Subnet 4, we ran into a few challenges. First, nobody has worked on this problem in like 20 years. Second, there's don't try using Google to find information on this. It's not, unsurprisingly, it's not there. And so, and also using a meta search engine or like using like a SERP API is very, very slow. Like it, takes up to a second to do a SERP. Whereas Google, it only takes 1 second. So why would someone want to use something that takes a second over 1 millisecond, right? So this is why it's really important that we build our own index so that it's really, really fast. But the internet is a very interesting place, I've learned. 90% of what we were indexing, there are these websites out there that are designed to break PageRank. And that's what we were using. I was like, oh, well, let's just use PageRank, right? Because, 20 years ago is where we were starting. We were getting caught up to the meta. And so there's a bunch of websites out there that all link to each other. So there's like a million of these websites. They all link to each other. And it's all adult material websites. And so it's like, you would like, okay, let's add a filter, like a URL filter, right? To block this sort of thing out. Like, let's do these other things. No, it's just like random strings and like these. So we had run into that. Okay, we have to make a better way of like crawling the information, right? And then second, we were constrained to Python for a long time. And Python is great unless you want to do something fast. And in that case, you're gonna have a bad time using Python. And that's what we discovered. I thought one of the main challenges of doing indexing on Subnet 4 was going to be going and actually getting the information, reading the information. But what it turned out to be was actually like storing that information is really hard. Because if you're writing that much information, if you want to index 200 million pages every single day, it's very hard for you to be able to write that fast and in something like Python. And so this is why we started working on these, like extracting out a lot of the Python, the Bittensor Python package, where we still can interact with Subtensor. Like it's all still Bittensor, right? It's just that like the metagraph is no longer a torch object. It's just JSON. And so syncing the metagraph in Go takes like that, right? Instead of like, 10 seconds.
Cool.
And so now that we have that capability, we feel very confident that after function calling, we can start working on not just having a database where like our own subnet where we have the database that's stored by the validators, but also be able to have an index where you can get these responses in 1 millisecond. So we now have a generally available open source search index that anybody could use as long as they have the bandwidth.
Right. Do you think that these changes that you're making to the way that the subnet works, but still allowing it to interact with the Bittensor network, that this is going to like propagate to the other subnets? Because this is one of the things, like when you start falling down the rabbit hole of Bittensor, you're thinking like, okay, like Now we've got, instead of one company, there's 32 different companies. They're all working on kind of like in the same incentive landscape. So there's many similar problems with like the reward models or whatever, but everyone's working on a little bit of a different thing. And then you have like subnets like yours, which are then creating these developments to reduce the latency by either writing in Go or doing an indexing process. And like the stuff that you're doing in Go, do you think this makes its way across the subnet sort of like divide and gets like pushed through the cell membrane of like subnet number 8 or something? Do you think that happens?
Absolutely. Like one of the really like tricky things about how it's done right now is like the way that we do like hashing in the Exxon and the Bittensor package. It makes it very hard to do it in anything other than Python. And so by opening up the ability to write it in any language very easily, right? Not so like there's like gonna be like a Bittensor TypeScript, a Bittensor Rust, a Bittensor Go. I think it's gonna pave the way for much, not just faster and more secure subnets, but subnets that are like easier to write. And so I definitely think that we're going to be able to see, these sorts of things. Like there's already a way to interact with Subtensor in pretty much every language, right? So like Polka.js, there's like a Go package that's based off Polka.js. There's Pi substrate interface. There's all these different packages for interacting that you can use to interact with Subtensor. But the actual communication that occurs, like the protocol.py file, right? We're going to be able to abstract that so that I can write my API that's querying subnet 8 in 2 different languages and it has no issue. So that'll be great.
This opens up the door too to more developers joining the project, right? Because it's not just like gotta be AI, ML, Python, or Rust, or don't come to Bittensor, right? I mean,
yes, you could write you could write a subnet in Swift if you wanted. Like that would be, which would be cool. That would be a cool thing. That would be, yeah.
I can't ask you about Swift that. I don't know what Swift is. Swift is like a new programming language, or what is Swift?
Swift is Apple's language.
Okay,
they used
cool.
to like program like iPhones but they have like, so it's like proprietary, but like it's not like proprietary. So there's not a lot of like community. I just really like Swift. Like I think it's a very wonderful language, strongly typed. But running it on like a Linux, on anything that's other than a Mac, is like kind of, an involved process. So I'm not going to subject anyone to that, obviously. I won't do that to y'all. But it would be cool. Like technically you would be able to do it now because it's all just based off of like, here is the JSON object that you are expecting as a miner. And so then you can just query it. So it doesn't matter what language you queried it in, as long as your JSON object looks just like this.
You mentioned community, and before we got on the call, we realized that both of us have a TinyBox pre-ordered. TinyBox is a project by George Hotz to create the most amount of teraflops, right, in a single box that you can actually just plug into the wall in a, I think it's a double plug to get the full out of it, the full, maximum compute. You can also just plug one in and get like 70% of the compute, and it's run, I believe, using AMD rather than NVIDIA. And like you mentioned, with reprogramming the way that your subnet works using Go, they've had this like mantra of like keeping their code base like super small. It's like less than 5,000 lines or something still to like run the TinyBox. How do you see something like that in these different or we could talk about Grok. You probably saw Grok, that the new like hardware or chip that's got like the response time for Llama 2 down in the 100 millisecond range rather than like ChatGPT, which is like, several seconds while you're watching it generate. How do you think like these different things find their way into the Bittensor network? Because you've already mentioned the attention that you're paying to latency. I think that's when someone is like thinking about like, yeah, but how is Bittensor going to reach the consumer in an effective way? We've got to get the latency down, right?
Yeah, and this is where I think that something in regards to something like a tiny box. I think something like tiny box will be really great for decentralizing the network on the miner side, because for the first time you won't need a data center. I don't know if you've ever done mining before, but like it is a pain in the butt because it's pretty much all in 240 volt. So like, like the washing machine plug. And so, I have some boxes at home, like these like big black boxes that will step up a 120 volt outlet to a 240 volt so you can plug a server in. But don't think about using any like actual significant amount of amperage because it will just turn off. So you couldn't run like a DGX at home. So this is why we see HPC and data centers where you have all of these like enterprise guarantees. So something like TinyBox, being able to plug it in to a 120 volt at home, anyone could run one of these things, and they're like 15 grand, which is expensive, but like in like the compute world, that's very, very, very affordable, like astronomically affordable. The one of these DGXs costs I think like $300,000. So if you had $300,000, you could buy one NVIDIA box, or you could buy a bunch of tiny boxes. And so I think that the biggest constraint here will be how many of these boxes can he make? Because he's already going to be, I guarantee, like we placed our order. I have notifications on for Mr. Box.
For sure.
And so, I see the tiny box being able to bring it out from like our reliance on things like RunPod and bring it into home, where something like that. It's also very general. So like if you stop Bittensor mining, you could still do training. Like you could train your own models. Like you have your own home workstation. You actually have a computer that in 2006 would have been the most powerful computer on the planet, and you're just able to plug it into your outlet like it's an iPhone.
Mm-hmm. Yeah, it's awesome. Yeah, it really changes the whole game because, like, for example, on the validating side, I've got every piece of hardware that I use, unless I'm going to be like transferring tau or something simple with the client, I use the cloud for. And
right.
Like for me, there's really no other option, like you said, because I'm not like not gonna like rent a house or like try and get an electrician in here to build in like 10 of these giant plugs and like take over an entire room, and the room's going to be 150 degrees because you're running all these big machines in there or whatever. Yeah, I think it's once the equipment becomes like commoditized and
yes.
we get over the hump from like this shortage of chips that NVIDIA, I believe like probably intentionally creates so that they've got, control the market and the price points and everything. I think that's going to explode the capabilities of the open source community. And I also think like, just like personally, the reason why I'm doing the tiny box, not only just to have a little bit of the compute that I outsource now for the validator at home, but I also think it's going to be like, almost like the Apple II was for like in the 80s or whatever.
Yes.
Like they were the first people with computers like down the block, Jimmy's got an Apple II. It's going to be like, Keith's got a tiny box. He's running his own like LLM that he trained. Do you think like that? Do you think we'll eventually create a system like is Bittensor going to be friendly for people that want to have their own LLM that they've like tuned to their cultural specifications or trained on a specific data set? Like, how do you see Bittensor being involved in like the LLM at home in the future? Do you think that's something that will do it as a network?
So I think it's totally possible. And there are different schools of thoughts on this. I have always hated UIDs. I've always hated like registration limits. This is the bane of Carro's existence. But for a long time, so like the reason why it was like that though.
So hold on 1 second. Yeah. So UIDs are slots on the network, yes. Right? So like yes. on your subnet, for example, you've got 256 slots available. Maybe 20 or 30 of those UIDs go to validators, and then the rest are miners, right?
Correct.
Okay.
And so for a long time there was a good reason for this, and it was based off of how long it took for the validators to be able to query all of the miners. And so there was like a power to the 2 time complexity for verification. But once we've done subnets, we've been able to kind of like get rid of that problem, right? Because now like the tempo is 360 blocks. And so even though we are like still writing a lot to the chain, everyone's on different block times now, if that makes sense. Like no one subnet is on the same interval time.
Mm-hmm.
Maybe there is 1 or 2 that are on the same time or close to it, but we don't have these same constraints anymore. And so if we could, we can only have, I think, about 8,000 UIDs on the network right now, or 8,000 clients in total, right? And I think that a big change that we could make is if everyone had tiny boxes at home. Let's say there was 10,000 people with tiny boxes at home, and we were all putting inside the request layer, right? This is something that Arash wants to build. A lot of people are working on this idea of building like a transaction pool where people can submit requests. And so if you had the miners watching the request pool, they could leverage something like Mev, like where they're all trying to race each other to get their answer first. You could scale the amount of clients that are actively able to use the network, because you wouldn't need UIDs anymore, since the miners are going to the pool instead of the verifiers going to the miners. There's still a lot of discussion around what we want to do on that side. I think that this is this idea would be in direct odds with something like dynamic tap, because you wouldn't need the root network anymore anyways. There wouldn't be any. It would be very similar to how something like Ethereum works, right? Where validators get their base APY, but they can make an extra amount of money by being a bundler on Flashbots. So now, instead of Antpool being able to order every single block, you can pay money to have a block ordered in the way you want, which is it's like now instead of Antpool meving you or sandwiching you, now anyone can sandwich you. And so this is, I think, a similar system would allow for an even greater amount of throughput, and would allow a lot more decentralization on the network, because you could have more than the total amount of slots. So you could have 100,000 different people inside the network in a system like that. So
cool.
This is where I think Bittensor should, and we should at least create a dialogue. I think that there's a lot of disagreements right now on in this regard, around the detail, how exactly are we going to do this? And so I think that prioritizing, or at least if we are making a long-term bet, we're going to buy a call option or long-dated call option on the bet that compute is going to become cheaper and more available to the consumer. Which I would like to purchase that, right? I would like to purchase that call. Mm-hmm. If that is true, then the Bittensor network will need more slots, right? Now we could just create 32 more subnets, right? And so then we would be at 64. But now 20 validators have to run on 64 different subnets. It stops, the scaling stops. We need to be able to upload our own, custom consensus. I want to be able to make a binary, a Wasm binary, and upload that to the chain. And that's what the validator actually is, right? So instead of everyone running these off-chain validators, you could have it on the chain itself, and then uh, you could query like the miners themselves, like whenever they submit for verification, it would be submitted through this custom consensus on Subtensor. So this is the way that my perspective, right? I'd love to hear what you think about it, though.
It sounds like the training wheels are coming off. You know, when you start talking about being able to like customize consensus, this is going to increase the not just the difficulty level, but like the responsibility level for a subnet owner, and probably start attracting more quality developers into the space because the sandbox just went from like this to like this, you know? And the
Yeah,
more that you can create like the network that scales that can have tens of thousands or hundreds of thousands of slots, then the bigger ideas start being hatched as well because you're not limited by the 256, right? I mean,
absolutely.
this is the way that the project has moved ever since I've been involved. Like originally, you know, I mined a couple tau just using like the base miner that was included with the client, and then got, you know, ran out of price, but not, well, basically just like the intelligence required to mine passed me by, and I just moved into the validation space. Like I hope eventually, like, and I say this all the time, like please extinct me. Please, like make me go away as a validator. Like if I tried to validate one day and I realized I couldn't because it was like too hard, then I know the network is probably getting to like a point where like even the validators themselves maybe are required to participate at a level that requires a certain amount of skill. And this has happened on the mining. I mean, it's kind of changed a little bit on the mining side because originally mining was very easy. And then with the single subnet, it got very hard. And then when we opened up back into more subnets, now all of a sudden it's like more miners can participate again. And the way that I always kind of try to explain it for new miners is like, listen, there's subnets where like you don't have a chance. Like you're never going to go into subnet 6 and get first place unless you've got some kind of ability to compete with teams of machine learning engineers, you know, like
Right.
TensorPlex or News Research or whoever's at the top of the leaderboard now. But then there's plenty of subnets where like all you need is the hardware or all you need is some spare storage. So like I like on the mining side the ability to like leverage the available compute that consumers may have or be willing to rent and not have the difficulty go through the roof. But on the developer side, like I know that the way to attract the best developers is to like break the bounds that exist today in the Bittensor space. So like I'm all for that stuff. It's hard to like every time you do one of those things, like you want to put enough change in that allows new things to happen, but doesn't like open up too many areas for exploitation or cabals or like break the system, you know. And Bittensor has had like many implementations where like, oh, stop for a few weeks, or like, holy shit, somebody's taken over subnet XYZ, you know? And like, that's all part of people, I think, are understanding more as they're involved in the project that that's like part of the evolution of this project is to go through these phases where like you're paying people in Tau to like red hat the thing all day long. And there's like good actors and bad actors. And yeah, I think like what you're talking about, it's part of the evolution. And with guys like you that have the knowledge that you do over the last couple of years that you've been involved in this stuff, like I have no doubt you're going to kind of shepherd this project into the right direction along with, you know, the team at Opentensor and the other subnet owners. So for me, it's exciting. I think some people come into projects like this and they think like, was it going to fork? Like what's like, but if you think about Bitcoin, like these conversations have been had and are still being had
Yeah.
across the entire Bitcoin community constantly every single day. If you turn on any Bitcoin podcast that's like a little bit deeper than what Bitcoin did, then mostly what they're talking about is like, how are we going to scale this? Like, can we make it anonymous? You know, like what about the transactions for buying, or is it just going to be a reserve asset? And there's this like, the evolutionary path of all of these things is part of the reason why it's so cool to be involved in this, is because it can go anywhere and it will go anywhere, because any space that is like open to be filled with like novelty is just going to attract like the brightest minds to build out into it, you know? So I love it.
Yes.
I
Yeah.
love the stuff you're talking about.
Being able to like, if we could have it to where we could support an incredible, like, a million subnets, right? Like all of these different kinds of projects. And then like mining was actually very sparse, right? So now as a developer, you have to like attract miners to your subnet, right? Like I think that something like that is actually really cool. And especially if you could like, drive it in such a way where like what they're trying to do with detail, where it's like a Uniswap pool, but like the way that the emission is determined on that subnet is based off of the usage or the amount of throughput going through something like the meta pool. Like, I think something like that where we're not having like two tokens and, oh, like if someone just prolifically mines my subnet for a month, they can take all the tau I use to register the subnet with. Something like that would be, I think, would enable, Bittensor going to even greater amounts of people, like where we have like a million clients on the network, which would be amazing. Like getting somewhere like that is going to, especially cheap as well, is going to drive such great outcomes for everybody because of what we were talking about, where this technology is so deflationary. If it's like generally available and super deflationary, if you want to be an entrepreneur, it's going to become so easy. In fact, we've actually just purchased a Unitree H1 bipedal humanoid robot. We're doing research. We're building what we're calling the Sybil model, right? And this model will run on this robot. It's shipping the next couple of days. We're so excited about it,
Awesome.
right? I'm really looking forward to when, like, we're getting one right now for developing our software. And so I think when we get it in a couple of days, it's going to be able to go on coffee runs for us and, walk up the hill and get the coffee and then come back and carry it all. What I'm really excited about is when something like these robots can use something like Bittensor to communicate with each other. So I'll have like 100 of these robots doing all different sorts of tasks for me, producing work for me. And then people always say, oh, well, what are you going to do? Well, I'm going to keep doing what I've always been doing, right? I'm going to keep researching. I'm going to keep trying to build new technology. I'm going to, try to continue increasing my productivity so I can save time. This is the one thing you can never get back is time. And so,
sure.
We're really excited about Bittensor, where we're at right now and where we're going.
How do you think about Bittensor itself, like as a project? Like what percent of it is like designing incentive mechanism versus designing like an optimal network versus the actual AI piece? Because we've been talking about some AI stuff, but for the last few minutes, we haven't really talked about AI. I mean, a lot of the network is actually more around creating an optimal environment for development, and AI just happens to be like the engine that you put in the car,
Yes. And this is even though we started building Bittensor with the idea of with a particular focus of AI, I think that over time it has grown into a more general compute platform. And this is really useful because now we can have all different sorts of AI models, but you can also incentivize uh, what what's it called? Dataverse. Have you seen this? Subnet 13, something like Subnet 15, where you can just incentivize swaths of data, right? Where it's just sitting there generally available. And it's like a redundant load balancer as well, where if one node goes down, well, you still have all these other nodes available to serve the information. And so I do think that while like on my subnet and a lot of other subnets, there is still a huge focus on AI, just because I think that Bittensor is really good at incentivizing and building that problem. I think what we're seeing now is like, okay, like if Bittensor was like this size when we were working on just AI, and now Bittensor is this size as we're able to add different kinds of applications on there. What happens to the size of Bittensor when we can have any application on Bittensor with the speed that's faster than Web 2, with security that is comparable to Bitcoin, and the affordability of something like Napster. I think that this is where Bittensor is ultimately heading. I think that if you, like when I was at ETH Denver and I spoke to a lot of other projects that kind of mimicking Bittensor, uh, I think that we're seeing the crab take shape here, where they're all kind of taking this approach or path, right? But with Bittensor, the scale that we continue to hit, like every year, like if you look at like where we were a couple of years ago, we were just had 2,000 nodes. We've already 4x the nodes in a year. And so, what happens if we 4x the nodes again? Now we're at 32,000. Then we 4x the nodes again. You see it compounds, right? So I think that it's really interesting to see these sorts of outcomes happening on Bittensor, and I think that we're just getting started.
I got to say this because it's kind of part of my Bittensor journey, but there's this this monk that's written a few books, and he's like a urban monk. His name's Yoon Rao. He was on the Duncan Trussell podcast a few times. He had this like near-death experience where like he was in a coma for a couple days or whatever, and he was taken on a journey by this, entity or whatever. But one of the things that he talks about on that podcast, and you keep mentioning it, is the crab. And he has this vision of like in however many years, hundreds or thousands of years, that the entire planet is like turns into this AI crab. And yes. I just think it's funny that you're talking about the crab, because this guy, like one of the things that he mentions in his afterlife sort of journey, when he eventually got pulled back from, is the crab. So that's crazy.
No, it's the crab is the optimal shape. So everything over in evolution, it's the optimal evolutionary path. Everything just like, no matter where it starts from, if it's underwater and in the environment that crabs live in, it turns into a crab. And so it's really interesting. And so when I say like Bittensor, I think we were just the first, right? But we're all of these, and this is where I talk about the waves as well with the peer-to-peer networks. Like we're all converging to a place where we could build something like a generally available, cheap, secure, and fast compute like network. If you think about what AWS is, fundamentally that's what it is. Except AWS is not cheap at all. Like it's one of the most expensive out there. I think that there are like products on AWS that people like. Personally, I've never used it and never will. It's too the SageMaker and all this stuff. I don't want to learn. Like S3, like you can go and use S3 buckets on something else, right? Like, and you don't have to use this god awful interface, right? Like, So this is also one of the things I really love about Akash, right? Is that you can think of Bittensor as like the app layer, but with something like Akash, you could serve your tiny box on Akash and then use that box or use Akash to serve your miner and then, or your validator, right? And so we could use decentralized compute on a decentralized computing, like our app layer, right? All the way up to where it is cheap, fast, and secure.
Yeah, and this is where like I see Bittensor and things like Akash too have like borrowed the best, attributes of something like Bitcoin, for example, whether it's from the tokenomics or like, we had our like Ethereum moment when we launched the subnets or whatever. And the timing for everything, especially with AI doing what it's doing now to be like the engine that powers this whole system. And to take advantage of all, like, I think it's going to become clear eventually that like crypto was created to decentralize artificial intelligence. And it's probably its most important mission statement behind the actual like, Bitcoin moniker of like, we're going to decentralize money and take the power back from the governments and the printing and everything like that. But I think that for me, like the technology aspect behind Bittensor and the things that it kind of like leverages to create these opportunities to go into this space and pull the power back from this like corporatocracy that has owned every industry on this planet forever. I keep seeing it speed up. And I'm seeing like, even though those guys like jumped out ahead, it's like a tortoise and the hare situation. And
Yeah.
they're for sure like getting a little bit tired, even though they're still in the lead. And you're seeing like all of these different mechanisms being like strapped onto the tortoise, and it's just going to like fly past the rabbit, eventually. You can just kind of see it coming. Just like you can see what's happening with Bitcoin now. You kind of knew that was going to happen eventually. You never really knew like what was going to be was it going to be the dollar debasement, or was it going to be some kind of like global currency collapse, or what, but you're seeing like all this huge outflow from like gold ETFs into the Bitcoin ETFs now. And Bitcoin itself is like on its own price discovery mission at this point. Bittensor's been on a price discovery mission for like the better part of 6 months now. It's a cool time to be a part of these projects. So yeah, maybe we could talk about, before we close it out, like you were just at ETH Denver, like seeing all the different projects and everyone's coming in there waving their own flag for something. Like where does Bittensor sit, like from the perception of everyone that's there? Like, is it kind of a more well-known project now that we're kind of like top 25 or whatever we got listed on Coin Market Cap? Can you talk about like the perception of Bittensor outside of our own little ecosystem bubble? Because for me, it's like hard to figure out. I've got my whole Twitter is just like Bittensor down the whole timeline. I don't know if I'm in my bubble or if like it's some. Okay.
No, everyone else. It's the same for everyone else as well. And this is what we kind of realized at ETH Denver. It was shocking, and I mean it's not shocking, but it's shocking, right? Like, I've been working on Bittensor for years now. I've been around since the very beginning. It's always been like, when I'm explaining to people, I'm like justifying, if that makes sense.
For
like,
sure.
Not like they're like, what are you talking about? It's always what it is. And at ETH Denver this time, I was like, oh yeah, we're building Subnet 4 on Bittensor. And they're like, oh, Bittensor. And then they start talking about like, oh, they know about it. Greg, the founder of Akash, told me that this Casey, who we did a panel together, went on ETH Denver main stage and did a demo of deploying a Subtensor node using Akash. I mean, that's where we're at. That's where we're at, right? Like, so I think that's super cool. At least now, like people, it's like, oh, have you heard of Bittensor? And they're like, yeah. It's like, okay, cool, Instead of it's like, okay, well, a neural network is, and
right,
okay, and then this isn't what an incentive is, and walking it through, like they're very familiar with it now, and so that's what's so super exciting about it, and or at least it's something that's super exciting, at least nowadays. Compared to like oh like when we're talking to people and trying to explain like this is what we're working on, and they're like this will never work. Like I remember Stella Biderman telling me this. She's a very good and smart person who works at Luther AI.
Mm-hmm.
She wasn't too jazzed about Bittensor a few years ago when I told her about it, but it was because she like misunderstood me. She thought I was trying to do decentralized training, which is something that happens on Bittensor, but like she thought that like, oh, you're going to use all these computers, like these different nodes, and then you're going to send like the weights across the wire, which it's like hundreds of gigabytes. So it's like just completely unfeasible to do something like decentralized training. I do think decentralized fine tuning could work though. Like what Noose is doing, the way they do it, I think that kind of is a really interesting idea, because like you could use LoRa, you could use a lot of different things like with one GPU. So if you're a consumer who wants to start mining on Bittensor, something like Subnet 4 might be bad, or Subnet 6 would be much better than something like Subnet 9, where you're going to need like an 8 pod or something. Or maybe you don't need an 8 pod, but you're pre-training, so I feel like you're always going to need more compute than fine-tuning. So, yeah, I just feel very, very fortunate to that we've made it this far. I always knew we would make it here, but actually going through it, I have friends who are like, oh, they're starting a new job, and they're like, oh, I hope I'm good at my job. Like they have like imposter syndrome, right? And like it's like, oh, this isn't, when I was starting my job at OTF, I kind of felt the same way. And so now have gone through this whole process, right? This is why I'm so excited about doing Manifold, because I can take all the learnings I have at OTF and apply them to growing Bittensor to, if we're at 8,000 nodes right now, how do we get to 80,000 nodes, right? I think that we are so early on in the adoption curve of Bittensor, like, so it just the amount of people that already know about Bittensor is super cool.
Awesome. So the company is Manifold. The subnet is subnet 4. And what are we calling? The Sybil is the front end, right?
sybil.com. Decentralized search. Go check it out. Or decentralized answering of search queries currently. But we want to we're going to have or function calling and indexing here soon. We're working on it.
Cool. Thanks a lot for doing this today, man. I'm thrilled to have guys like you involved in this project and kind of, like I said, shepherding it into the next wave, whatever that is. And I can't wait to see what you guys do with Manifold and the next subnet that you launch. So thanks again, and I'll see you on the Discord.
All right, I'll see you there. Thank you so much. I really appreciate it.
All right, see you, man.
Bye.
Cool. All right, we're done.